I promised you to discuss about microservices development in a other aspect. In other words, what are the common mistakes developers do when they work with microservices. But I am not going to talk about mistakes. I am going to talk about in a positive way, which means I am going to talk about what are the good practices what we should follow when we do microservice based implementation, right. So, when you know the best practices, you can avoid common mistakes. Sounds good, right? Okay, the first one, design. So, design should be domain driven design, right. So, in the last video we discussed customer can represent two different services, but in two different aspects. Customer registration or as account management service, you can have a customer a creation part. But when you do support module or support service or other service, the same customer can represent in that module in a different aspect. But that service, the main scope is customer support, right? Or in other service, the main purpose of that service, main domain is finance or account or payable, whatever. So, when you design a service, when you think to move to microservice, you need to make sure you have a fresh domain driven design. So, most of companies, most of team I have seen, they are just moving to microservices to say, hey, we are on microservice. That does not work, right. So, let us say you have a web application, right. Let us say the same rent-a-car application, right. So, you have a inventory module. So, you have stakeholder module to register stakeholders. So, you have a search module. So, you have renting module and you have a finance module, right. So, you can't put all together and create one or two service and say, hey, our company run on a microservices. That does not work, that is the wrong practice. So, it is always okay, I understand, I can suggest go for rewrite, but that totally depend on how much company can spend on this, right. So, what is their budget? But my recommendation, think to go from fresh as much as possible. You may not need to write everything from the beginning. So, what you can do, rethink. Okay. So, if there is something inside your service which is not relevant to your service, take that out, right. So, in that case we do not need to write, we do not need to redesign and rewrite everything, but we can do little tweaks and we can isolate and we can make our service independent to your domain. So, that is first practice. Second point is hard coded values. So, usually other than the business logic, there are some configuration parameters, right. So, last time we discussed with the microservices, one disadvantage is we are distributing this complexity or maybe some metadata. So, just assume your one service is calling other service, right. For example, before you your rent vehicle to the customer, so you may call other service to get customer history, right. So, now this service A, for a easy of understanding, let us say A and B. So, your A service calls service B. So, now you have to have a service B address, right. So, most of developers what they do is they hard code this maybe host name, maybe URL, maybe IP address on service A. So, now service A knows where service B is. The problem of this, if your network team decide to change the host name or they decide to change the network address or something like that, you are in a trouble. Why? Because you need to send other deployment. You need to change the code, you need to send other deployment. So, this is not nice and this is not correct. So, what you can do is there are enough service discovery mechanisms, right. Maybe service registries, right, or something like that. So, you need to use some kind of service discovery tool to discover the second service. So, with that you can implement some circuit breaker patterns kind of a thing, right. So, my next video would be some patterns what you can use in the microservices. So, I am not going to do that right now, but just think like this, like, okay, service A going to call service B, right. Okay, so now service C also needs service B. Now, service A sees the service B is offline, right. So, now service A, the service discovery tool can host some flag, okay, hey, service B is offline. So, before service C call service B, service C can see service B is now offline, right. So, there are patterns like that, we can detail discuss all those patterns. So, the advantage you can use whatever the mechanism, you can use a proxy, right. So, proxy has other main disadvantage if you not properly use proxy, right, because it can inherit other services issues to different services contagions. So, I am not going to detail analysis what is best and what is not, but the second point, you should not hard code foreign services addresses, rather you should use service discovery tool for that job. Third point is logging. Developers struggle through logs because either they do not have logs or either they do have too much logs, right. So, both is bad. So, why it is bad? Just think like this. So, in let us say you have a service to validate customer, right. So, this service internally call different methods. This is not relevant to microservices. I am taking this web example, web application example to explain this. Okay. So, you have a service layer. So, you have a repository and you have maybe let us say domain layer or DAO layer, something like that, right. So, now what happens is, let us say your one service, when you are trying to validate the customer. So, it goes to service layer, some exception happens, right. So, now you log it and you come back, that is fine. Other scenario, you go to service layer, right. So, you go to repository, now you call some Hibernate or some other persistence framework layer. So, there you get exception, right. So, now you logged it, right. So, you log on DAO or maybe let us say repository layer for ease of understanding, right. So, now you log in a repository. So, now your repository called from your service layer, right. Now, what happened? So, service layer sees this exception, right. So, now you log in a service layer, same error, one error logged twice, this is bad, right. Why bad? So, when you trying to access logs, when you are trying to debug through logs, it's the same error logged twice, right. So, it will really hard, right. So, the best practice would be fail fast, log late, right. So, if something is fail, just come back immediately, but do not log, right. So, last layer, keep the logging responsibility on a last layer. Okay. So, let us say layer 1 call layer 2 and layer 2 call layer 3, right. So, third layer you got some exception, right. So, now do not log there, come back, do not log in a layer 2, come back, log on a layer 1. This is directly not applicable to microservices world, because microservices perspective you may not maintain those type of things. So, what the point is, do not do too much logging, do not log everywhere, right. So, log wherever you initiated the process, but keep in mind you must log the stack trace, okay, or some other information to understand where this really happened, right, because otherwise you will be misleaded saying this error happens on a service layer, while it is exactly happen on cause on repository layer, right. So, this is I hope you understand, this is very important. You need to log only once for a particular error and make sure you do not lose any information throughout this journey to understand what has happened. But there is a other perspective involved for microservices, right? So what is that? So let's say you got a request to service A, right? So now it go through several layers of the service A and call service B, and go through other several layers and call service C, right? So just think somewhat you need to debug this. You can't understand, right? So you don't know where it went, what happened, right? You can say it failed, but you don't know where it failed, right? So as a developer, you are the person who exactly know where these traffic are routed through your services. So one good example, one good practice, usually I do follow this. So when you hit the initial service, you can generate a unique ID. We usually call this a correlation ID, right? So maybe your web server can generate that somewhere before you hit the your service layers. From beyond that, you can generate this ID, right? Let me to explain this in a simple way. Just think you get a request to allocate X vehicle to Y customer, right? So before you get this request to your service layer, microservice layer, you can ask your web server, you can implement some script or something, or proxy, whatever. If you can't do that, you can come back to your service layer. Very initial point, you generate particular ID, right? So let's say 001. So now from 0 very first service, when it come to first service first layer, you log something like info level logging, okay? So service initiated, right? So when you use, let's say for example you use log4j, right? So when log4j trying to write this statement to the log, so you can use either log appender, some people call log interceptors. So you can use log appender to write those correlation ID or whatever the ID you generated, in this case 001, to your log file along with your log statement. So log will looks like date time, debug info, and 001 service initiated, right? So now if we, when we do this thing on each and every log entry, so you can track your service calls at any given time, right? So you take one service and you search through logs, so you see where it initiated, where it next time, next, where it go finally, and where the exception happens, when it came back. Very easy. For that, you, if you have a separate log files, it would be really hard. But rather than that, you can use some frameworks or application or some product. If your company has money, you can go some thing like Splunk, which is a very good, very extensive log management framework, or else you can go Logstash or whatever, maybe open source framework, something like that. But make sure you have some kind of log aggregation mechanism to search through the logs, okay? So this point, logs is very important, need to maintain proper logging, and also make sure you log, debug, warn, error, info in a separate category, separate level to make it sense. What make it sense mean, right? So if something is failing, don't log as a warning, right? There is no point of log as a warning if you fail something, right? But let's say you get a request, you need to call service B, right? So your business logic says if service B is fail, not responsive or something, go service C. So in that case, you can log, okay, tried service B response fail, going to service C. You can log something like that. But if you're failing your thing, don't log as a warning, log as errors. That's a separate different topic. I'm not going to dig into that. Point is, log is very important. Other very important topic is versioning. How you should version your service. When you do next deployment, what would be your version numbering? So if you're not familiar with the semantic versioning, please go and read about that semantic versioning, because that would be the good governance mechanism to version numbering. So for example, it explain you when you if it is a bug fix, which digit you should increment, and if it is a new functionality or change of functionality but it is backward compatible, then which digit you should change, and if it is breaking existing functionality, and if it is not backward compatible, or if it has new functionality, which digit you should increment, like that. So, now it is good practice to follow the semantic versioning, because then everyone, when someone sees the u version number, they exactly know if we call this version, we are currently calling this version, when we call this version, whether we have a possibility to break or not. Now, point is this, right. So, there is a concept called force upgrade. Okay. So, what it means, understand this very carefully. Let us say you have a service called service A. This service A call service B. Okay. So, now you need to update this service B, right. So, during this update, what you do is you are changing your database structure. So, this the service request would be different. So, now when you know exactly, now you do not have to run any test, right. You exactly know when you push this new version of the B service, your A will break, right, no option, right. So, now what you can do is you can increment major version number and you can deploy this as a separate service, right. So, now you have a B service version 1.00 and B service version 2.00, right. So, 00 is different, but just as example, right. So, now your traffic still take to version 1.00, but you can talk to consumer is we have this functionality, you must update to this functionality, this version on before this date, because we are going to decommission existing service, right. So, if you have more than one consumers, you can give them some time frame to update to your service, right. So, when all consumers are migrated to version 2.00, so you can shut down and decommission version 1.00, right. Also, you can use elastic mechanism. For example, let us say you have 5 consumers, right, and you are running 10 instances of version A, version 1.00, sorry, version 1.00. So, when consumers are migrating to version 2.00, you can increase instance of version 2.00 and you can decrease versions instances of 1.00. So, with this way you can manage your services without breaking anyone. Now, important point, how this deployment should take place. Certain developers believe they should control everything, but what I am saying, do not try to reinvent the wheel. Wheel is there, right. So, you do not have to invent it, use it. So, there are enough deployment tools, right. So, you can deploy your service, multiple services in a single host, or you can use one service, one host. In this case, host mean not the physical box, host mean operative environment. So, that is why most of microservice developers are really love with Dockers, right. So, because Docker generate you isolated operation environment for you, right. So, you have one service per Docker, right. So, now you can create a Docker when you need more instances, you can create more and more Dockers, right. When you do not need, when you have less demand, you can shut down and destroy the Dockers, right. So, that is why microservices and Dockers go together, because one service per host concept. Do not confuse, this host is not the physical box, but when you are implementing microservice on a Docker, you should understand this Docker concept, right. So, I have a different video to explain what is Docker, right. So, if you are creating one Docker per one physical box, does not make sense, right. Or if you are installing one VM on one physical box and create one Docker per VM, does not make any sense, right, because the physical box has operating system, then VM has operating system, then Docker, right. So, why you need create a VM, you can just deploy Docker on physical box, right. So, do not try to create hybrid solution, unless otherwise you exactly know what you are doing, right? If you know what you are doing, that's fine, but otherwise that is not recommended, right? Because before you alter existing mechanism, go back and think what this mechanism mean to, right? What this microservices mean to do, right? What Docker mean to do, why Docker came, right? Because VM is older generation, the Docker is the next version of that, right? So now if you are trying to create a hybrid solution, what really you are going to gain? Because I feel and I believe you are losing much than you are gaining. Next point is authorization and authentication mechanism. If your each and every service is tried to validate the user, then it will add more and more latencies to your round trip. For example, let's say when user trying to allocate vehicle to customer, let's say it's invoke 3 different services. Okay, so just assume you are using OAuth token to validate consumer. So when you just and assume you take it take 20 millisecond to validate OAuth token. When this request comes, if it is going through 3 different services, if those 3 different services trying to validate this OAuth token separately, then you are in a trouble because you are adding 60 millisecond to your round trip. So, what you can do is you can have a separate identity validation service, and whenever whatever the request hit to your service layer, you can direct to this identity service, and if it is successful, you can direct to rest of the path, right. So, we say as a force forwarding, we forcefully forward to particular service, right. So, with that you can avoid some latencies, as well as that would be a good practice, because at any given time you can change this validation process or authentication authorization process based on your algorithms or your service decisions. Next point is dependency. We should avoid any dependency for my service, right. uh, why? Because let us say you have a ABC 3 different services, right. So, when you want to deploy A, if you fail to deploy B and C together, then there is a problem, right. So, independency is must. We should be able to deploy A or B or C service separately without worrying about breaking others, right. So, the next topic is make executable contracts. Okay. Why? If you take just normal application, the usual users are consumers, right. So, we have uh, consumer experience or otherwise user experience mechanism to make sure users are really liked to your website or your application. But how about your service? Your service also has users. Those are consumers, maybe your front end application, right. So, it is your responsibility make your service is easy. It is your responsibility make them happy, right. So, in your ABC service structure, when you deploy B service, if certain consumers are breaking, then you did a bad job, right. So, I took a negative part. So, you did a bad job. How you can avoid this? You and your consumer has a contract, right. So, maybe API specification, maybe something like that. How you can make sure this contract is not broken? So, what you can do is you can convert this contract to executable one. What I mean, you can prepare some test cases, maybe test scripts, maybe some request, right. So, whenever you make a build of A or B or C particular service, those tests will execute automatically, right. Continuous integration tool will execute those tests, right. So, if those tests are not failing, and I mean those tests are passed, then you know you did not break them, right. If those tests are failing, you are 100% sure when you push this to production, you are breaking your consumers, right. You can fix that fast. I have other 2 different topics to discuss. I will make it quick because I am running out of time. So, one is fault tolerance. right. So, since you have a multiple services now, right, you have multiple possibilities to have for failures, right. So, you need to properly manage those. For example, let us say your service A calls service B and service B calls service C, right. So, if service B is timing out, if service B is slowly failing, if service B is taking long time to respond, then you need to make sure you fail very fast, because when you waiting on when you waiting service B to respond, right, you are creating other queue behind you, right. So, let us explain this in a next video with the patterns, but keep in mind you have to have a strong fault tolerance mechanism, because otherwise people, when people complaining microservices is bad and then standard web application is a good, monolithic applications are good, because the main reason they say is the fault tolerance, because they do wrong, that is why they fail, right. It is not about microservices, it is about where you understand. So, other one is documentation, the developers most like part. Okay, I know you guys do not like to write documentation, because I do not like, um, but it is must, otherwise how other person will understand. So, Swagger would be alternative, right. So, you can write document in a technical way, right. Swagger will take care to convert to very nice and attractive documentation, right. So, you can use like a script, it is not a scripting, but you can write technical terms on a Swagger console. So, Swagger will take care and generate proper documentation. Not only the documentation, it gives a UI, so consumers can come and refer the documentation and try out some services, right. It is that much nice. So, Swagger is something you should go and try to learn if you are sticking on these microservices or any web application development platform, right. So, there are more to discuss, but I am running out of time. So, if I am doing another video, I will try to cover up more, but I can promise I discuss main parts of these best practices, right. So, recap those, go back and try to list down and try to understand. If you do these type of these things, that is good, and if you do more than this, you can welcome to add some comments, so others can others also can share your ideas. Okay. So, let us meet on next video.